Welcome to episode 2 of the CNC Router Fixture Plate. I'm Jörg from JBWorks Studio. By the end of today's episode, you will have an exact understanding how thread milling on the CNC router works. Now, to finish up the fixture plate, I have to make 153 M8 threads. And I'm going to use a single point thread mill to do that job. There's also a multi-point thread mill. The disadvantage of a multi-point thread mill is that it can only make one pitch, one type of thread. The single point can make different types of threads. And I think for a hobbyist, it is not as expensive because you don't have to purchase one for every single thread you want to make. Now, how thread milling works on the CNC router, I like to explain in the following sketch that I made for you. So here we see a cutaway of the M8 by 1.25 millimeter thread. Now, to make that thread on the CNC router, we need to feed the CAM system a few pieces of information. The major diameter of the thread is almost 8 millimeters, 7.97. So it's about 2 or 3 hundredths of a millimeter less. And then we have the minor diameter. The minor diameter is the original hole that we made into the material. And that is 6.8 millimeters. And that is the hole that we cut 153 of them last time in the last video. Now, the next piece of information is the pitch. And the pitch on M8 standard thread is 1.25 millimeters. There's also a fine thread, and the fine thread is 1 millimeter. Now, to find that pitch inside the thread, all what we need to do is look from one valley to the next valley, to the next valley, to the next valley. That is where the pitch is found. Or from one peak to one peak to one peak, we have a dimension of 1.25 millimeters. That will be our pitch. So let's have a look here at the thread mill next, and I'm going to make a bit of a crude drawing of it. And where I want to focus on is that bottom edge. The triangular area on the bottom is actually a 60-degree triangle. And most of the iso threads in the metric range that you see have a 60-degree. And the triangle here, we find that back where we machine that out of that hole. It's a material that we have to basically carve out or take away. It's that red area that I marked right there. That is a triangular shape of the tool. The way it does that is that it interpolates a helix going up that hole all the way back out, and that helix has a pitch of 1.25 millimeters. And there you have it. Our thread is made. Now, we always take more than one pass when we cut that thread. And that's mainly because the cutter would have some tool deflection, and it's small, it's a small cutting edge. So let's take a look at that cutting edge one more time. There's something I don't like in Fusion 360. So let's say the material that we have to cut away to make that M8 thread is 1 millimeter. Then 1 millimeter in 3 passes is 1 divided by 3 is 0.33 millimeters. Now, if I take that tool edge right here and I slice off 3 equal slices of 0.3 millimeters for my depth of cut, then the first one will cut hardly any chip away. The second one will cut much more, and the third one the most, as you can see here in the yellow outline. And that is not good. It should be even. It should be the same to have the same chip load because we have the same feed and speed. Now, my choice would be 50, 30, 20. If we make it 50, 30, 20, we have pretty much that area of the triangle even out. Unfortunately, Fusion doesn't allow us to do that. So let's have a look how we find the pitch on imperial thread. As an example, we have a 1/4 thread. So a 1/4 thread has a major diameter of 1/4 inch. And the 20 means that we have in the length of 1 inch 20 threads. always will be a full number. So the pitch, we still need to enter that pitch into the cam system, and the pitch we can find again from peak to peak or valley to valley. And what is that dimension here? Well, it's 1 inch divided by 20 threads. So that is 0.05 inches. So our pitch for a quarter 20 is 0.05 inches. No rocket science here, relatively easy once you understand how thread milling works.
Thread mills are expensive, and it's a good idea to set up a foam part or a test part to just get the parameters correctly before you do the first cut. The first row of parts is going to be different, as we have a mounting part for the plate right under it. So these are going to be blind holes, and I have a distance of about 0.2 millimeter from the bottom of the end mill to the top of the support surface. So let's see if we hit this dimension correctly, and here goes nothing. This is now the second row of M8 holes, and this is a little different because now we can go all the way through. There is nothing that is below the plate, and I programmed the bit to go 1.5 millimeter past the bottom of the plate, so hopefully it will go all the way through. The next thing that I did different is that I programmed the passes different. We had four passes and 1 spring pass, and now we're going to see 3 passes only, no spring pass. Hopefully it will still make a good surface finish, and the fit of the screw will not be impacted too much. Further optimizing the program, I was able to achieve 10,000 RPM. That is a surface speed of 200 meters per minute, a feed rate of 200 millimeters per minute, 3 passes, no spring pass, and that results in a good fitting thread. The machining time per hole is now roughly 40 seconds, 45 seconds, where we had before with the 5 passes, they were slower with the spring pass, about a minute and 45 seconds. So we cut about a minute out by optimizing further the program. And that's important when you machine 150 holes.
So the reason I made this step down here with 10 millimeter diameter is that I can use it for locating something. And the way I want to use it is to take a shoulder bolt and screw that in. That thread fits really nice, but it's poor in positioning something. So the ground section of the shoulder bolt will precisely engage into that 10 millimeter diameter. And now when I cut the head off of this, I can use it, for example, 2 right here and 1 here to put a pallet into the same position, or reposition the vise into the same spot every single time. And that is why I made it that way. And there you have it. Cutting threads with a CNC router. I'm really happy how this turned out and that the project is finished. I can use my fixture plate now. You might think, hey, wait a minute, you had a spoil board before. Don't you need that back? Yes, I will make another spoil board. And the way I'm going to do that is I'm just going to cut slats actually and screw them down onto the fixture plate, and then having a space in between them, I'm going to use that space exposing the threads that are there to fasten something down. Now, in next week's video, I am going to review the bearings that I use on my machine, especially the fixed bearing. And I'm going to disassemble that a little bit and have a look of what can be improved. So I hope I catch you then. Bye.